Okay, any questions from the worksheets?
I have a question from the other worksheet.
Yeah.
Can you go over number 6 and 28? No, 23.
Okay, so we'll do 6 first.
Yeah.
By breaking each from the components, turn the result into the following vectors. Okay, so we have 10 meters, 30 degrees north of east. So that's going to look like this, 30 degrees north of east, 10 meters. And we have 6 meters, 37 degrees east of north. So that's going to be 37 degrees, 6 meters. And 12 meters, 30 degrees west of south. So that's going to be 30 degrees, 12 meters. Okay, so if we break each one into the components, we have, so like these are all displacements. So I'm going to say D, let me just change my pen for a sec. So D1x will equal 10 cos 30. And then D1y will equal 10 sine 30. And D2x will be 6 sine 37. And D2y will be 6 cos 37. And then D3x will be negative 12 sine 30. Room here. And D3y will be equal to negative 12 cos 30. Okay, so that's breaking them all into their components, and then determine the resultant of the following vectors. So if you add them all together, 10 cos 30 plus 6 sine 37 minus 12 sine 30, you get 6.27. So that's the x. And for the y, you would get 10 sine 30 plus 6 cos 37 minus 12 cos 30. And that's negative 0.6. Yeah. And then you could add those together. Like just say, okay, so that's 6.27, this is negative 0.6, and then figure out the resulting vector.
Yeah, I got it. Sorry, but can you also go over number 16 as well?
Yeah. Okay, 16 must cross the 260 meter wide river. Oh, this one sucks. Okay. I had trouble with this one too, so don't feel bad. So what the ferry's doing is it's pointing 45 degrees upstream. So let's say it starts right here and it's going 45 meters that way. Its speed is 2.85 meters per second. Okay, so that goes there. Now the river's speed, because like normally we would say, okay, like if a boat wanted to cross a river, it would go like that and then plus the river speed and it would go just directly across. So it's actually like the boat speed plus the river speed is like where it ends up. So in this case, the boat speed plus the river speed makes it land there. And that distance is 110 meters from where it started, like 110 meters upstream from where it started. So if you apply this, what you can do is the river itself, so this is 45 degrees right here. The river itself is 260 meters. So that means this is 260 meters wide. And you can figure out that velocity. So that velocity that it crosses the river with, 2.85 sine 45, doesn't matter if I do sine or cos, is 2.01. So I just called it 2.0 meters per second. And so what that does is it can give you a time, I guess. So where am I going with this? Like, oh yeah, okay. So that speed, as I said before, the speed that it crosses the river with is unaffected by the river. And that's how you know it's going to be 2.0. Now, if you were to figure out this part of the velocity, so the horizontal velocity, well, because it's 45 degrees, it's also going to be 2.0 meters per second. And the time that it takes to cross the river is going to be distance over time. So 260 divided by 2.01 or whatever. So 129 seconds. The time it takes to do that, the boat is actually going to go 2 meters per second that way. And then the river is going to bring it back. But if it's the exact same time, 129 seconds, then it's the exact same distance, 260 meters. So that means that from here to here is 260 meters, which means this is 150 meters from here to here. And so if the boat is traveling, let's say it travels forward 260 meters and then back 150 meters because the river is going to bring it back, then it's going 150 meters in 129 seconds, which is the speed of the river. 50 divided by 1.16 meters per second. Okay, so I'm using the relationship between the velocities. So if the velocity in the x direction is the same as the y direction, and it's going that way for the same amount of time, then it's the exact same distance. So that's how you get the 150 right here. Does that make sense?
Yeah.
Okay. And then 23, right? You have to remind me what number it was.
23, yeah.
Okay. Pilot wishes to make a flight of 300 kilometers northeast. And every time it says northeast or southwest or whatever, it just means exactly northeast, so 45 degrees. So 300 kilometers northeast in 45 minutes. So that's what the pilot wants it to be. So if you figure out that in a velocity, 300 divided by 45, 0.75. So that's 400 kilometers per hour. 400 kilometers per hour. And that's northeast, so 45 degrees northeast. If there's to be a wind that's 80 kilometers from the north, so it's going south for the entire trip, what heading and airspeed what must she use for the flight? So the way this works is like if you were to look at an airplane on the ground, like up, you're looking at an airplane in the sky from the ground. That speed, so the ground speed of the airplane, is the velocity of the plane plus the velocity of the wind. And so if she wants to make the flight of 400 kilometers an hour in 45 minutes northeast, that would be this one right here. And so we want to know what heading and airspeed must she use. So we want to find VP using VG and VW. So we're solving that. So VP would equal VG minus VW. Okay, so the velocity of the ground, which is what she wants to make happen, this 400 kilometers an hour. So that's going to be that. So this is 400 kilometers per hour. And then minus the wind. Now the wind is 80 kilometers from the north. So the V wind is this right here, 80 kilometers per hour. Okay, that's VW. But because we're adding the negative VW, right? This is what we're doing, VG plus negative VW. We're adding the negative. So we're actually going to add this, 80 kilometers per hour. I'm making it longer than it has to be because 80 versus 400 is very small, but I need big enough to show that angle. So that's 45 degrees. If that's 45 degrees, this is 45 degrees, that's 90. So this is 135. And then you can use cosine law to solve for the v plane. Okay, and you don't like, this is the way you do it in vectors and all that stuff. But if you think about it, if a pilot wants to go northeast, but there's a wind blowing it south, right? Like if it wants to go there, but there's a wind blowing it that way, then it has to go that way in order to end up there, right? So you all you're doing is countering. You're trying to think about it in a way that makes sense. That like, okay, if that's your starting point, that's your end point, but there's something that's going to make you go there. Well, if you're going to end up there, you can take that into account and aim there so that by the time you make this distance, you're at the right spot where you want to go. Okay, so you can do it that way too. Does that make sense?
Yeah, thank you.
Yeah. Any other questions from anyone else?
I actually got stuck with 11. But
11?
Yeah, but the first worksheet.
First worksheet.
Yeah.
That would be this one. Okay. What is the acceleration of a bullet that was shot 40 meters per second in the horizontal and then changed to a velocity of that? Okay. So with these ones, we're dealing with the formula. I don't know if I put that anywhere, but the formula is A equals VF minus VI over T. And so we need to figure out this VF minus VI thing. So what is the acceleration of the bullet that was shot at? So this is our VI, 40 meters per second in the horizontal.
Yeah.
And then change to, so this is your VF. So if we're doing VF minus VI, that's the same thing as VF plus negative VI. Then we can draw our VF first. So I'm assuming it's going to be going horizontal that way and to that way. It doesn't say which direction it's going, but let's just assume it's going in the same direction in the horizontal kind of. And so my VF is going to be that, it's going to be this arrow right here. So like this. So this is going to be 44.5 meters per second. And then that's 26.1 degrees below the horizontal. So this is your horizontal. So that's 26.1 degrees like that. And then what we're doing is we're going to add the negative VI. So VI is originally going to the right, which means negative VI would go to the left. And we're adding that to our VF. So this is our VF right here. So we're adding the VI to that, going back this way. Okay, and this is 44.5, this is 40. So I know that it's going to be going this way a little bit. Okay. And then you can solve it that way, I guess. Now, in this case, it doesn't really matter how you do it. But I would say, I always use cosine law, but I guess I'll show you how to use components. So the bullet's going to go like this part of the VF is going that way, VFX, and then VI is also in the X direction. So like your delta V, because this is your delta V right here, the X portion of your delta V is going to be, so delta VX is going to be VFX minus VI. Okay, so it's going to be 44.5 cos 26.1 minus 40. Okay, so all I'm doing is this line minus this line to get this line right here. So that's going to be 44.5 cos 26.1 minus 40 should be negative. Okay, so that's negative 0.04. So that's like barely anything. And then your Y portion of the delta V is coming from the Y portion of the VF. So whatever that is, 44.5 sine 26.1 is 19.57. So this is, so your delta V is very little X and a whole lot of Y. And we'll just call it 20, I guess. And this is pretty much 0. So let's just call it 20 meters per second downwards is your delta V. And so then if you divide that by 2, you get 10 meters per second squared downwards. And that should be, what number are we doing? 11? Yeah, so pretty much. It says 9.8, so I'm rounding up. Which makes sense because that's acceleration due to gravity.
Oh yeah, I got the same answer, but the answer says 9.8.
Yeah. 9.810, same thing.
Okay.
Yeah, because I'm just rounding, right? Like I'm not taking.
Yeah.
I'm just assuming it's 20.
But like, Mr. John, I do a little bit different way. Like,
Okay.
I don't just match the line. I draw the line from the 0. So I just make 2 lines, and then I connect them with a little triangle between them, and then I calculate the triangle.
Okay, so we'll connect after this lesson, and then you can explain further what you're doing so I can see what the method.
All right.
Sound good?
Yeah,
Okay. Okay, any other questions?
Can you also do number 8 on the same worksheet?
This number 8?
Yeah.
This one? Okay. Draw and add the vectors. So 200 meters per second, 20 degrees west of south. So that's going to be, I'm just trying to figure out how to draw this. Okay. So this is 20 degrees. This is 200 meters per second. And then to that, we're adding 15 meters per second, 20 degrees west of north. So that's going to be that way. That's your north. That's 20 degrees west of that. And this is 15 meters per second. So I'm just going to close this like that. So this is the I don't know what to call it, the velocity, I guess. The outcome of adding the two velocities together. And then if this is 20 degrees, this is 20 degrees. So that gives us an interior angle of 40 degrees. I'm trying to do cosine law now so that we can kind of see both methods. So this one's going to be V equals 200 squared plus 15 squared minus 2 times 200 times 15 times cos 40. Does everyone see how I'm getting that 40?
Yeah.
Yeah?
Mhm.
Okay. And then if we do it that way, 200 squared plus 15 squared minus 2 times 200 times 15 times cos 40 equals the answer. So this is 188 meters per second, and then we need this angle right there. So sine theta over 15 equals sine 40 over 188. So 15 sine 40 divided by the answer, sine that. That's like 3 degrees. 3 degrees. And so I would say that the answer is 188 meters per second. And then it's 20 degrees west of south, but then another 3 degrees. So 23 degrees west of south, like that. I don't know if that's the right answer. I think this answer key is really messed up. Oh yeah, no, that works. Okay, so again, for everyone here, all you're doing is drawing the first vector, okay, which is this, and then you're adding the second vector to that, which is that. And then that forms a triangle. You don't even have to do the triangle. You can just break it into components. Okay, so if I were going to do this the component way, I would I would originally draw my vectors so that I know which way they're going. So like this one's going that way, this one's going that way. And then I would say, okay, this X is going to the left. So then I would go like 200 sine 20, but to the left. And then this one's also going to the left. Actually, I should draw it like this. So what I'm doing is I'm taking that and I'm breaking it into a triangle, and I'm using the 20 degrees right there because that's west of north. And so I would say negative 15 sine 20. And so that would be my X. And then my Y would be 200 cos 20. And again, that's negative plus 15 cos 20, like that. Okay, so you don't have to do it the vector way where you draw the whole triangle. You can actually just draw each individual in its component triangle and then add the components together. You get the same answer. Okay. Next questions. This is good. I'm glad you guys are asking questions.
Lastly, can you do 25 on the, that.
On this one? Yeah. 25. Ooh, okay. So for this one, hiker leaves camp and using a compass walks 4 kilometers east. So what I did is I grouped them into like east-west and south-north. So like this is, and then I'll put positive negative on it. So 4 kilometers east is positive 4, because that's to the right. And then, so this is the XY, or this is the X, this is the Y. And then 6 kilometers south would be negative 6. And then 3 kilometers east would be plus 3. What happened there? Plus 3. And then 5 kilometers north would be plus 5. 10 kilometers west would be minus 10. 8 kilometers north would be plus 8. 3 kilometers south would be minus 3. That way. And then all you're doing is, so that's 7 minus 10, so that's negative 3. And this is, oh, I might have messed this up. I did. I had the 6 as positive, didn't I? That's probably why.
Yeah.
So I had it as 16. Yeah.
I was wondering why you got 16.
That's probably why.
Yeah.
So yeah, so if that's the case, this would be 4, I think. 13 minus 6. Yeah. And then you'd go negative 3 plus 4, and then that way. Yeah, that's the answer key's totally wrong. Whoops. See, second day, second mistake. 1 mistake per day.
Okay. I got it right, so okay, good.
Perfect.
Thank you.
Yeah. Okay. If you have any other questions, and you don't want to ask in front of everyone, that's fine. Just message me later and we can go over things. Whoops. I didn't want to add a page. That's okay. Okay, so this notes package, like it's a big file. Not that big, but I think most of them will be like this from now on, where I'll like give you all the notes at once, and then you can print off a whole package, and then we'll just go through them day by day. So this topic, this unit only has 3 lessons in it. So we're gonna do the first lesson today, and then we're gonna do the next 2 lessons tomorrow. And we'll see where we're at by Friday. We might do, we'll start the next unit on Friday, but it won't be a lot. It'll be very little. Okay, so this unit it's dealing with forces. So just as a kind of a review, do you all remember what a free body diagram is? I'm hoping you do. Okay, so like if I were saying to say, like, let's say a book was on a table. Okay, if a book is on a table, we have FG going down, we have normal force going up. Okay, if we were to tilt that table, okay, your FG would be going down still, your FN would be going that way, and then like hopefully your teacher taught you how to break these into components. Have you guys heard of FG parallel? Did anyone not learn that?
Yeah, I heard it.
Yeah. Did anyone not learn that? Like inclined planes? No? Okay. So your free body diagrams is drawing forces coming from the object. So that's what this unit sort of is. Now, when we have F net is the sum of the, well, that's not the sum of all the forces. And so that's like the sum of all the forces in a plane is your net force. Translational equilibrium, or equilibrium in general, is when the net force is 0. Okay, so the sum of all your forces has to equal 0. Now, in the first lesson, translational equilibrium, all the forces are going to be acting at one single point. Okay, so in the first example, that point is right here. All the forces are acting on that point right there. Now, we kind of have to explain that in a way, because technically that's not true, because technically the gravity of the actual sign is acting right there, but the gravity is pulling down on a rope, and the rope is pulling down on 2 other ropes. So this is the point where the gravity is felt by these 2 ropes. So you kind of have to dig a little bit deeper and figure out where all of that is. But so technically, like for this sign or this object, we have gravity going down and tension going up. But because the thing is just sitting there, this tension is equal to the FG. Okay, and so that means that if I draw it like this, where I have the tension going down, because it's a rope pulling down on these 2 ropes going up, then this tension is the same as the FG. Okay, so it's digging a little bit deeper and making a few assumptions so that we don't have to deal with all of that other stuff. So obviously this object is going to be at rest. Okay, the net force is 0. It's not accelerating anywhere. It's just sitting there. The first method to solving these, and it's the same as solving vectors, is breaking it into components. Okay, now if the sum of all the forces is 0, then the sum of all the forces in the x direction has to equal 0, and the sum of all that forces in the y direction also have to be 0. Okay, and that's what we're using. That's what we're going to use to figure all this out. So if I were to apply that to this question, so I'm just going to redraw these up there. Okay, so we have tension 1 going up to the left and up, tension 2 going to the right and up, and then tension 3, I guess, or FG. You can even just call this FG, because if that FG wasn't there would be nothing. So yeah, let's call it FG, is going down, straight down. So if I want to do this in components, what I need to do is figure out the components of my forces. So T1 is going to be going that way and that way. And I'm breaking it into this triangle, because if this angle right here is 35, then this angle right here is 35. So I'm breaking it that way. And I'm going to do the same thing for T2. T2 is going to the right and up like that. And again, this is 50 degrees. Okay. So if I'm going to go X direction things, then I'm going to say negative T1 cos 35. Okay, that's this one right here, T1x. And then plus T2 cos 50, so that's this right here, T2x, is equal to 0. Okay, because those are the only 2 forces I have in the x direction, and it has to equal 0 based off of this right here. Okay, so if I do that, then I can figure out that T1 cos 35 is equal to T2 cos 50. Okay, and that makes sense. There's only two forces in the x direction. They have to balance each other out. Okay, so that's for the x direction. For the y direction, what I have is I have T1y plus T2y, and then my FG. So it's going to look like this: T1y plus T2y, and those are both going up, which is why they're both positive, minus FG equals 0. Okay, and so we can already kind of make some assumptions here that FG is going to balance those two forces that are going up. And so T1y is going to be T1 sine 35 plus T2y, which is T2 sine 50, equals FG, like that. Okay, and then we want to solve for T1 and T2. Now, I have two equations here. Both of them have T1 and T2. So that means we're going to have to solve one of them for one of the variables and plug it into the other one. So in this case, I'll go T1 equals T2 cos 50 over cos 35. Okay, so I'm just solving this one for T1. And then I can plug that in over here. So now T1, instead of writing T1, T1 is equal to something else. So I'm going to substitute that in. T2 cos 50 over cos 35 times sine 35 plus T2 sine 50 is equal to FG, and FG is 64. This is 64 Newton object. And then, I know this is a lot of work, T2 cos 50, and then sine 35 over cos 35 is tan 35. Okay, sine over cos is tan. Plus T2 sine 50 is 64. Hopefully the other way is easier. And then factor out your T2, cos 50 tan 50. Oops, tan 35. Almost made a mistake. Plus sine 50 equals 64. So then, this is a long one. 64 divided by bracket cos 50 tan 35 plus sine 50 equals 52. So T2 equals 50, and we'll call it 53 newtons. Okay, are there any questions about that? Did everyone follow the reasoning there? Did I lose anyone right away? Okay, so then once we have that, we can just plug that into the first equation. So T1 will equal T2, so 53 cos 50 divided by cos 35, which is 42 newtons. Okay, so I'm just plugging the 53 back into this equation right here to get my T1. Okay, so it's not easy by any means. Like, it's not, yeah. Let's try a closed vector diagram and see what is easier. And this is part of the reason why I prefer closed vector diagrams, because at this point, it's going to be much easier. So if instead of breaking into x, y, okay, where we're saying the sum of the forces in the x direction is 0, sum of the forces in the y direction is 0, we're going to say the sum of the forces is 0. Okay, so if you add all the forces together, you're going to get 0. Okay, now think about displacement. Okay, displacement, if I start here and I walk that way and I walk that way and I walk that way and I walk that way, if I end where I start, my displacement is 0. Okay, the same thing is true with forces. If you end where you start, you're back at 0. So I'm going to add all of these together. So I'm going to go T1. So it doesn't matter how you add them together, but I'm going to go T1 plus T2 plus FG equals 0. Okay, that's the way I'm going to do it. So T1 looks like this. Okay, and this, which is, where's that? This is 35 degrees right here. Okay, plus T2, and T2 is a little bit steeper, so it's going to go up that way. And then plus FG equals 0. So plus FG, I end up where I started. And I know for a fact that this FG, where's that 50? 50 is right here, 50 degrees. I know for a fact that the FG is going straight down. Okay, so I know that it's like the FG is only in the Y direction, so I know it's going straight down. Now this is T1, this is T2. Now if that's 50, this is 50, which makes this angle 85 degrees. This angle is 40 degrees, which means this angle is 55 degrees. Okay, and so now, and FG is 64. So now we can use sine law. Okay, so let's go T1 over sine 40 equals 64 over sine 85, and see if we get the exact same answer. 64 sine 40, 40 divided by sine 85, and you get T1 is equal to 41.3. So we're kind of off, but I did round the 53 and the 42, so that's probably why. And then we can do the same thing for T2. T2 over sine 55 equals 64 over sine 85. 64 sine 55 divided by sine 85. And you get T2 is equal to 53 newtons. Okay, so which way is easier? I'm pretty sure you're answering closed vector diagram. Because it makes more sense. It's way less work. But we got the same answer. So again, I don't care how you do it. And it's not like you're in a classroom where you have a certain time limit for tests. So if you take longer by doing it the component method, I guess it doesn't really matter as long as you get the assessment done by midnight. So yeah. Any questions? No? Okay, let's do another example. We have 2 more examples. Okay, object is suspended as shown. If the tension in one of the ropes is 50 newtons as shown, so the up one, what is the weight of the object? So I guess the first thing to do is draw in your forces. I'm going to change colors because black on black is a little bit, I'll go blue. Okay, so T1 is going to the left, T2 is going up and right, and then we have FG right here as well. Okay. And remember that it's technically tension, but that tension is because of the FG, so we're just going to write FG. And it doesn't matter how you draw this. So in this case, I can draw any force I want first. So I'm just going to go like this. That's T2. Okay, so this is 50 newtons plus T1, which is going directly to the left because of this right angle right here. So that's T1. Plus FG. FG always goes straight down. FG. So that means that this is a right angle. And this angle right here is 37 degrees. 37 degrees. Okay, and so this one's really, really easy because now all we have to do is sine 37 equals FG over 50. And then we get FG equals 50 sine 37, which is 30 newtons. Okay, and that's pretty much it. Now, that's technically not the easier way of doing it because if you look at this, there's only two forces in the y direction. So T2 or T2y has to equal Fg, right? So T2y equals Fg. But if you do it that way, what you end up with is 50 sine 37 equals Fg, which is exactly what we just did. Okay, so it doesn't matter how you do it, you're going to get the exact same thing. Okay, example 3. I'm actually going to give you guys a little bit of time to try this on your own, and then in, let's say, 5 minutes, I'll jump in and show you how to do it. Okay, so you guys try it first, and then I'll jump in and try it and show you. All right, go for it. Just let me know, like, when you're done, I guess.
Mr. John, I have a question. Is mass and gravity, I mean, Fg are same?
No.
No. Okay.
So this is your mass.
Yeah.
And then Fg is equal to mg. So mass times gravity.
Okay. Yeah.
Okay. Is everyone ready, or you guys need more time? All right, no one's answering, so I'm just going to go ahead and do it. So this is the point of equilibrium right here, and that's so FG of the person going down, and then we have T, we'll call it T2 and T1. Okay. And so let's just go with like T2, and I'm exaggerating these a little bit just to make them bigger. And then FG, T1, like that. And then angles of 10 degrees. So that means that this is 10 degrees, and technically this is 10 degrees. So that means this is 10 degrees, so this is 20 degrees. And because they are both 10 degrees, that means that these angles are the exact same. So this is 80, this is 80. And then we can just use sine law to figure this out. So that the man is 70 kilograms, so that means his weight is going to be 70 times 9.8. So that's 686 newtons. Okay, I know some teachers use 9.81. I use 9.8. I'm hoping that's okay with everyone. So then we'll just go T1 over sine 80 equals 686 over sine 20. And like T1 is going to equal T2, so we don't have to do it twice. 686 sine 80 divided by sine 20. So tension is equal to 1975 newtons. Okay, any questions about that? Okay, the worksheet package for this unit is in the Files tab, and there's, I think, 3 different sections. So 1 for translational and then 2 for the next lessons. So only do the first one, obviously. Don't do the torque ones that we haven't talked about. Actually, while we're on OneNote, so if you go to OneNote, you'll notice how every student has their own page up at the top here. So I believe OneNote is free, regardless of whether you have a Microsoft account or not. Now, this is going to be super easy for the Surrey School students because you could just log in at OneNote with your Surrey Schools info and it'll show up. But for those of you who aren't Surrey Schools, I think you just sign in with the email that I added you to the team with, and it should show up. So like, I know Hans, you're not a Surrey School student. So if you look here, there's a tab. Like if you log into OneNote and just message me if you have troubles with this, I can guide you through it. But I'm assuming that if you log in, you'll have no problem with the login that I added you to Teams with. What I'm going to do is, I said originally I'd do everything on Microsoft Forms, but Microsoft Forms doesn't allow outside access. So if you don't have a Microsoft account within Surrey Schools, you can't access it, which is really stupid. So I'm going to try use OneNote instead. So what I'm going to do is on the quizzes tab, I am going to upload the quiz to this page. All you have to do is either print it off or on a separate piece of paper, answer all the questions, and then click add page, and then file upload or insert, file printout, and then just take a picture of what you're doing and upload it to this page. That's all you have to do. Okay, and then I'll mark it directly on here. Only you and I can see this in your tab. And so that's how we're going to do things for now. I tried Google Forms, but that's causes problems too. Because yeah, I don't want to try that. So that's what we'll do. And then yeah, so if you have any questions about that, give it a try, and we'll have to figure things out on how it works. Okay, so that's it for today's lesson. Any other questions?
Can I stay in the chat and ask some questions?
Yeah. Yeah, I'll stop the recording and then anyone can leave if they want.
Yeah.
Any other questions?
I'm on OneNote right now, and it's not like showing a physics section.
Okay. Did you sign in with the
Like the
correct
email that I joined this with?
Yeah.
Yeah.
Oh man. Okay, let me look into this. I got to figure out. Yeah, we're having huge problems like district wide with guests on Teams. So I'll
Okay.
figure something out.
Okay.
Yeah. So that like what I'm going to add on there today is the not the equilibrium, the vectors assessment, the quiz. But obviously, if not everyone has access to it, then I'll have to figure out something else. But yeah. Okay. Okay, so I'm going to stop recording. Kanwoo, I will stay on and help you.